Okay, number one is proportional controller. The constant for proportional control is Kp. P for proportional. K is constant. So in this proportional controller, they will use present error to process it, and the output of the controller is proportional to the input. If the input is negative, output will be negative. If the input is positive, output will be positive, and also if the input is 0, output will be 0. So the proportional. The input is depend on the the output is dependent on the input. Okay, let's derive. Kp. Let's say this one is ut. Output. The error is the input. Okay. Ut output is proportional to the input. Ut is equal to Kp times Pt. So Kp will be equal to, go here, 15 over 50. So Laplace transform it. So we will get Kp will be equal to Us over Es. Okay, this is Kp. So we can say that this is gain. Input divided by input is equal to gain. Okay. To apply it, so for example, this car, we have to draw the block diagram of the control system. Reference. This is our reference, is our output. Okay. Okay. When this car, let's say this car turn to the left, so that means it move here. So the distance here, let's say this is in positive. Let's say positive 0.5. Okay, our reference is 1. Let's say our reference is 1. So the output is 0.5. So means that the sensor will sense 0.5. So 0.5 here. 1 minus 0.5 is 0.5. So the controller, the output of the controller, so they use the present error. The present error is 0.5. So output will be 0.5 times Kp times the gain. So the plant will use this input to process it. Maybe the output will become 0.7. Let's say, for example, 0.7. Then this 0.7 will be sensed by the sensor. Then this is 0.7. Okay, this car will turn back. 0.7. So 0.7 here, it will become 0.3. This will become 0.3 times Kp. And then sense process maybe 0.9. So our car is here. Okay, now is for positive cases. Okay, for example, if the output 1, let's say 1.3. For the output 1.3, so this one is 1.3, here 1.3. So So the reference between output and the output is will become minus 0.3. So our controller it will become minus 0.3 kp. So it's present and the output is always proportional to the input. Now the input of the controller is negative, so the output also will be negative. So this signal will be used by the plant to process it. Maybe then the output maybe the output is 1.2. Just to 1.2, then process back 1.1. Process back. Okay, 1.1. Okay. Okay, if we draw, you can say like this. The output will be, okay, this one our reference. This is YT. This is T. So the graph of the output will be like this. So this one we call steady state error. Okay, normally for proportional controller, the steady state error is quite high. It's maybe around 10%. The steady state error. Okay, this is the drawback, the disadvantage of proportional controller. Steady state error high. Steady state error high steady state error. The advantage of disadvantage of proportional controller. However, the advantage of proportional controller is fast response, very fast response. They get because they present error. They use the present error. They use present error to process. So the output is proportional to the input. So the very fast response. They get the error, they process it. So the advantage is fast response. Fast response. So the disadvantage is high steady state error. And also one more disadvantage of proportional controller, if our gain is quite high, it will produce overshoot. If gain quite high, it can be produced overshoot or unstable. For example, if this coil is the gain quite high, when this coil is moving left, if the gain quite high, it is unstable. Okay, this one is for proportional control system. Very fast response. This advantage is very fast response. Disadvantage is unstable, overshoot, and high steady state error. Okay, to solve this problem, we can use integral controller to solve the steady state error problem. Integral controller, the second controller. Okay, proportional done. So now is integral controller. Okay, in integral controller they use pass error. Pass error to process the error, and the output of the integral is the integration of the error. Integration of the error signal. Let's say this error signal. So integration the output of the controller. This output of the controller. Okay, we focus on the controller part. So UT is equal to integration of error. So we will get constant. It is constant for integral controller. Ki, integral controller constant. So we Laplace it, we get mu as equal to Ki 1 over S ES. So US over ES will be equal to Ki 1 over S. Okay. Ki 1 over S. That one is constant for controller. Okay, now we go back to our block diagram. Okay, block diagram. Okay, the block diagram. K I or S. YS RS minus plus. So okay, before this graph is like this. It's a reference 1 Y3 T. Output. Okay, previous one steady state error is high. Okay, steady state error is high. For the previous controller, proportional controller, steady state error high. So now in this controller they use pass error. So this is called, let's say this error, they use the pass error. So this controller will integrate this area under the graph. Integrate this area to solve this the area, integrate this area to solve, to produce the output, the error. So then the error, the input of the G will be, let's say here. So the graph will be shift to here. Then for this part, the integration will be used this area. So then the error will be moved to here. Then okay, finally if you plot, the graph will become like this. Okay, so now the steady state error, we can see that the steady state error is reduced. Okay, using integral controller. Okay, this is the advantage of integral controller, reducing steady state error. Okay, we also can from this block diagram we can see that this part is Ki over S. Ki over S. Okay, then when this part times this part will become times G over S. So we can see that it looks like we divide by S, then this start will our denominator. So yeah, numerator and denominator. So the denominator part will be at S here. So means that the type number of controller will be increased. So number of S here, number of pole. Because number of pole means that the type number of the controller will be increased. Then for type number increase, the steady state error will be reduced. We know that in previous topic. However, for higher type number, their advantage will be low stability. Advantage, low steady state error. Okay, low steady state error. Disadvantage, is low stability. So this one is the advantage of the integral controller. The advantage is the steady state error is reduced, low. So very good. However, the stability is not very good. In order to solve this advantage of low stability, to solve this problem, we will use derivative controller. Okay, derivative controller I will explain in the next video. Okay, thank you.
Beda je di satu.